For the purposes of this video, we'll be playing a simplified version of poker where the entire deck consists of only the heart cards. You and one other player are each dealt a single card from the deck, after which there will only be one round of betting before you and your opponent reveal your cards, and the player holding the card with the highest value wins. Initially, the two of you will be fighting over a communal pot of $50. But let's say your opponent decides to up the ante by betting an additional $25. Your options now are to fold and forfeit the money, call your opponent's bet by risking 25 of your own dollars, or further raising the stakes by betting an even larger amount. In this video, we'll be focusing on whether calling, that is, matching your opponent's bet, is a good idea. Let's begin by taking note of some basic information. You've been dealt the 6 of hearts, which means you beat hearts 2 through 5, but are beaten by hearts 7 through ace. Since you win against 4 of the 12 cards your opponent might have been dealt, and lose against 8 of them, we can summarize this information by saying that you have a 1/3 chance of winning and a 2/3 chance of losing. Now, based on this information alone, you might be tempted to conclude that calling your opponent's bet would be a bad idea here. After all, you're more likely to lose than you are to win. But it turns out that the story isn't that simple. Let's say you decide to call the bet, risking $25 to see if you've landed in the orange section of the pie instead of the blue. We'll record the fact that of the $100 in the pot, you've contributed 25. What we're after is whether or not this decision is profitable in the long run. In other words, whether you can expect to make a positive profit when faced with the same situation many times over. Let's say you face it 99 times. You can expect to win 33 of these rounds and lose 66 of them. Of course, this isn't guaranteed, but statistically the number of rounds you win out of 99 is more likely to be close to 33 than it is to be far away from it. Now let's work out how much money you can expect to make or lose over these 99 rounds. The number of rounds you can expect to win is equal to your probability of winning multiplied by the number of rounds you intend to play. With a win probability of 1/3 and 99 rounds, this comes out to 33 expected wins. Each time you win, your net profit will be given by the total amount of money in the pot minus the amount you contributed, which in this case works out to be $75. Similarly, the number of rounds you can expect to lose is given by your probability of losing multiplied by the number of rounds you intend to play. As we saw earlier, this gives 66 expected losses. Each time you lose, you don't receive any money, but you still forfeit your contribution to the pot, which is the $25 you put in to call your opponent's bet. Now we're ready to calculate your total profit over all 99 rounds. You'll be making $75 for each of your 33 expected wins and losing $25 for each of your 66 expected losses. This results in a grand total of $825, meaning the decision to call the opponent's bet turned out to be profitable in the long run after all. Let's now take the total profit and evenly distribute it among the 99 rounds to calculate the average profit per round. With a total profit of $825 split over 99 rounds, this comes out to roughly $8.33 per round. Here's one example of how those 33 wins and 66 losses might have been distributed over the 99 rounds. Although things get off to a bit of a rough start, you can see that the profit ultimately trends positive in the long run. If we now draw a line connecting the $0 profit you had before round 1 to the $825 profit you had after round 99, the slope of this line will be the average profit per round that we just calculated. And this turns out to be the key idea. As long as your average profit per hand is a positive number, you can expect your overall profit to trend positive in the long run as well. Let's now return to our previous calculations and see if we can distill a general condition that determines whether calling the opponent's bet is a good idea based on the call amount and your odds of winning. Keeping in mind our goal of ensuring a positive average profit per round, let's expand the expression for the average profit using the expression for the total profit. We can further expand the expected wins and losses using their own expressions. Notice here that the number of rounds shows up in the denominator as well as in each term of the numerator, so we can cancel it out completely. If you've had some prior exposure to probability theory, you'll notice that the resulting expression is just the expected value for your profit per round. Another way to phrase our goal is simply to have a positive expected value. Now we replace the profit per win and the profit per loss using their equations, and we're left with an expression containing only the basic information we started with. Since there's no possibility of a tie, we can replace the probability of losing with 1 minus the probability of winning. After grouping like terms and cancelling, we arrive at our final expression for the average profit per round. Using the fact that we want this to be greater than 0, we can work out a relationship between the probability of winning and the fraction of the pot that you contributed. And this gives us our general rule. In order for a call to have positive average profit, and therefore be profitable in the long run, you simply need to make sure your probability of winning is greater than the fraction of the resulting pot that you would contribute by making the call. Bringing back our initial pie charts, we can see that in this case the call is favorable because the orange slice of the left pie is larger than the green slice of the right pie. Poker players refer to this cutoff condition as pot odds. Now, it's important to take stock of the assumptions we've made that led us to our conclusion. Aside from playing a drastically simplified version of poker, we've also been assuming that the opponent would make the same bet regardless of the hand they've been dealt. Real players will obviously adjust their bet size accordingly, especially if they themselves are aware of the concept of pot odds. But this is still a great first step in approaching poker from a more mathematical perspective.